Welcome back. Here's another video in our unit on functions. This one is about quadratic functions. Let's see what that's all about. Now, the first thing we need to know about quadratic functions is that they are not straight lines when we see them on a graph. They're actually curves that we call parabolas. This is kind of a U shape when we see it in its complete form. Sometimes, though, we're not going to see the entire U shape. We might only be seeing a portion of a parabola or a quadratic curve on the graph. And the rule for these quadratic functions, of course, isn't y equals ax plus b. Those would be straight lines on a graph, and a quadratic function is a curve. Instead, quadratic functions are represented by the rule y equals a times x squared. And in that rule, x and y are going to be variables, but the a in front of the x squared is going to be replaced by some number. And if that a number in front of the x squared is negative, that means our parabola is going to open downwards on a graph. If the a value is positive, you guessed it, the parabola opens upwards. Now that a value also controls the steepness of the curve. The further away the a value is from 0, the steeper the curve, whether it's positive or negative. And the closer the a value is to 0, the flatter the curve is going to be. Now we can't confuse this a value with slope from y equals ax plus b. In a quadratic function, it does not represent slope. It's not the constant rate of change of a straight line. All we need to remember about the a in a quadratic function is that it does control the direction and the steepness of our curve. Now, outside of this course, quadratic functions can actually get a little bit tougher than the y equals ax squared that we see here. But luckily, we're only using this basic form, y equals ax squared, and what this tells us is that every parabola that we see, every quadratic function, is going to pass right through the origin at its vertex. What that means is the very bottom or the very top of the parabola, the point where it changes from increasing to decreasing, is always going to pass through the point 0, 0. And that could end up being a good trick for identifying that what we're looking at is a quadratic function. A curve that passes through the origin at 0, 0 in this course is going to be a quadratic function. Now let's look at a couple of examples of how they might ask us questions on quadratic functions. In this first example, we're given an xy pair of values that lie on a curve, and we've got to find what the a value is in this quadratic rule. So given that this quadratic function passes through the point 4, 38, to find the a value, all we're going to have to do is plug the 4 in where we see x and the 38 in where we see y. Now after I plug in 38 where y is and 4 where x is, I've got to square or raise that 4 to the power of 2 because that's what the rule tells me to do. So I actually end up with 38 is equal to a times 16 after doing that. And if I divide both sides by 16, I've isolated my a value. And in this case, a comes out to being equal to 2.375. So the rule for this quadratic function that passes through the point 4, 38 would be y equals 2.375 x squared. Now let's say now in a second example we were given the quadratic rule y equals negative 0.5 x squared. And we want to know, given this rule, what is y if x is negative 8? Well, all we have to do here is plug negative 8 in where we see x and then square it. But be careful here, negative 8 squared is positive 64. So what I've got is y equals negative 0.5 times positive 64. And when I multiply negative 0.5 times positive 64, I get an answer of negative 32. So the answer here is that given this rule, y equals negative 0.5 x squared, when x is negative 8, y is negative 32. Now lastly, if we're given a rule, something like y equals 1.25 x squared, and we know that the y value is 45, could we find the corresponding x value? Well, here we just plug the 45 in for y, and we end up with 45 equals 1.25 x squared. Now to start isolating that x, I'm going to divide by 1.25 first, and I end up with 36 equals x squared. Remember, that exponent of 2 hasn't gone away yet. And to isolate x, to get rid of that squared that's on top of it, I'm going to take the square root on both sides. So that leaves me with an answer of 6 equals x. And what that means is, given the rule y equals 1.25 x squared, if we know the y value is 45, we can solve for the x value, and in this case, it's 6. Now somebody out there might be wondering if x could also be negative 6 in this case, since negative 6 squared would also give an answer of 36. And the answer is yes. In this case, we were asked about a positive value for x, but the answer could have also been -6. And this is actually the exact reason why quadratic functions look like U-shapes. They've got positive and negative sides to that parabola. Now that is it for our lesson on quadratic functions. Of course, they might mix in quadratics to some tougher, wordier Part C questions on an exam, and let's see one of those using the quadratic rule, y equals ax squared, right now.